Test, test. Okay, perfect. Ciao, Cluj-Napoca. I think it's pronounced correctly. Just a thumbs up if it's corrected. Okay, perfect. I have some family in Timișoara, so I know some words like La Multiani or something like that, but there it stops. So you can talk to me in Romanian, but I won't understand it because I'm from Germany, as you can maybe hear it from my accent. And English is not my first language, so maybe I have some sentences I will jump over. I will welcome you to my presentation, step-by-step application security architecture. So mostly I do this kind of presentations for software engineers. So I don't know what people are here. There are some security people, some software engineers. Do we have software engineers here? Okay, kind of a few, quite a few. Who's in security mainly, like application security, information security, and such things like that? Okay, perfect, perfect. Good to know, because that helps me tailor the presentation a little bit and maybe catch some phrases left and right. Shortly about me, who is this guy talking in front of you? As I said, my name is Rico, Komenda. I'm from Germany. I'm working for Adesso SA. They also have a subsidiary here in Romania. I think it's in Bucharest. I'm a husband and a father of two. My second child came in April last year, so it's a little bit over a year. And it's just fulfilling all my needs, not in application security or security in general, but also in my life. So who's not a father or a mother now, I can encourage you, it helps you for your career also. I'm an international trainer and speaker. This is my second time speaking internationally. Mostly it's in German or German-speaking countries. The last international conference I visited was in Oslo this January. The NDC security. I'm doing consulting mostly. My roots are in software engineering. So as you know, consultants, I will always say, it depends. So this will also be like for this kind of presentation, because some things it's just depending on what we are working on. My pillars in consulting, or general what I'm working in my expertise areas, are application security, cloud security, offensive security. I've got some projects and yeah, some timekeeping in offensive security, and lastly, Jason told it earlier, everyone wants to do AI. I do also AI since like mid of 2023, and mostly the application security part of that, or like technical aspects to large language models or machine learning algorithms. My mission statement is we need to secure the digital world one byte at a time. It's just a catchy phrase I will use everywhere. And it's just so we can't be everywhere and we can't do everything, but we can do what we can do right now. And we will talk about this kind of area, and we also want to secure all parts of that. Just some figures or numbers, because I always have them in my slides. Those are German tailored, so that's maybe good for you to know what's happening outside of Cluj or Romania. In Germany, we had some statistics, like 2022, we had like 136,000 registered cybercrime offenses. This is like 3% compared more than the year before that, so 2021. And how does that happen? And we saw it with Jason's, or also with the previous talk before that from the Wolf, that the threat landscape just advances and advances more. And the professionalization, like the Wolf said, is getting stronger every year. They operate like companies, they operate like big groups, and cybercrime as a service or ransom service as a service, everything is a service right now, and you can buy it and you can deploy it in a matter of minutes or seconds. So what we know is that cybercrime is a professional business. But if we compare it to how it happens in the most times, we are talking about the path of least cost or resistance. So for example, I have here this beautiful picture from Microsoft. I stole it from them. And when we have an attacker, when we have a castle and our money, what we want to keep from attackers is right behind the mountains, as we can see it on the right of the picture. So the attacker will go to the barrier or to the castle which blocks the way to what I want as an attacker. And then he's saying, okay, I can't go there, but what if I can go the other way? And maybe this is the thing where you go around of something, and this is the path of least resistance, because there's nothing I need to advance more. And I have to, in this case, the money, but in other cases, maybe I have occupied the whole network of the company. Also, if we look at application security, and maybe you know that, for application engineering or software engineering, you have like multiple phases in a project, right? And you go from requirements where you get the requirements from stakeholders, customers, or so on and so on, and go back or go till the finish line to the deployment of your product or project. And every part of that you can secure. Of course, you can secure it. You can secure everything if you want to, and have the money for that or the time for that. So if we look at the software development lifecycle a little bit closer, we have like developer know-how, which is starting at the beginning, like we have junior developers, senior developers, architects, and so on and so on. And they have different expertise, and we go to the tool stack of all the software development lifecycle. And for every, and I walked a little bit back to when I was preparing, I know maybe you can't see it in the back that good, but I think the slides will be shared after the conference, so, well, while the conference, I don't know I don't know exactly, but you will get the slides. Otherwise, you just contact me and I will send them to you. And in every part of this software development lifecycle, we have different kind of attacks or problems we face. But for every part of the software development lifecycle, and I call it, or the most of the people in application security call it, the secure software development lifecycle, shortly SSDLC. And you can do for every phase of the software development lifecycle something to mitigate the issues you face there. And this could be everything, from code security analysis reviews till vulnerability scanning of the artifact we've built, till threat analysis before and after the product has been deployed. But most times we still face an issue in software engineering, and this is DevOps is really good, and there's some discrepancies how we define DevOps, but most times when I look at the cycles in a DevOps project, is that we have like 100 iterations of development, then we have 10 iterations of operations, like we're deploying something, and then we have one iteration of security. This could be like a threat modeling, this could be like a pen test, but most times what I see in companies is that there's still too less of utilization of security know-how in the company, or what is done in the software development lifecycle. So there were some creative people and just okay, let's do security around it. And then I know there's some kind of definition, like do I put DevSecOps in the middle because it's the center of attention, or put it like on the left, and you maybe hear it like SecDevOps because security should be shifted to the left because, okay, you look to me, so I need to move to my right, but you know what I mean. Because why, and that's why I have it in my slides, why do people put it left of the DevOps wording definition? They put it left because it's to be saying, okay, I have my traditional security model and it's happening a little bit later of my software engineering project, and I want to have the least of, how it's called in English, it's weathering. You want to utilize the know-how, the toolings, and the money on the early of the beginning of the software development life cycle, so you don't have to pay that much in the back of the project. And what I'm talking today about is like software architecture design principles. So you can call it a unified concept of architectural guidelines, but you can call it also secure by design principles. And I don't have like, okay, you have like a mono repo, or like you are in this kind of Microsoft stack, or you're in a mean stack, or otherwise software engineering stacks. It could be Python, could be PHP, it could be everything. And because it's like that big of a landscape of software engineering stacks, you can't, or I won't show one particular design. So just more the secure by design principles. And we will look at, I think, 8 or 9 of them. The first one will be assume breach and zero trust. And I will dive just a little, scratch the surface of all these design principles, because in all of these design principles you could dive in and have like 2-hour workshops or 3-hour workshops for every one of them. After that, we will look at a little bit at defense and dev. And then maybe if we have some people from ADs or configuring ADs, they will know principle of least privilege, but you can also use it for application security or architecture designs. Principle of failing securely, supply chain security, security by obscurity, and this is where I will put a little bit of fun into it, and attack surface reduction, and most importantly, the last point, usable security. Because most times when I face some C-level people, they are saying, okay, why should we need that? It's just costing money and we don't have something we can leverage off it. Let's jump right into the first topic, assume breach. What is assume breach? You're designing you design as your foo have already been or will be breached. So you go into the mindset and be like, and that's what the previous talks was a little bit about. Okay, I know that I'm being breached. I know it. It's not where. It's just a matter of time, not of who or where. It's just a matter of time. So okay, I will get everything in my architectural principles into that thinking that, okay, we are breached in this kind of section of my application architecture, or maybe you don't need to just, as you can also use all those principles not for software architecture, also for IT architecture as well. And you should, and that's what most CISOs or SOCs are working on, react as you have been breached already. So, okay, you maybe have some concepts and you know this kind of architecture consumer, or like this kind of area of my architecture is working, and what is done or what is happening there when it's breached. If we are looking at the other side of this slide, we will see zero trust. Zero trust means basically no implicit trust between components, apps, networks, system, and users. So every component of your architecture should be solely thinking that I can't trust this one, even if all of it was developed by yourself or by your project team and so on and so on. And after that, even if it's like, and that's the inside threat actor thinking a little bit, that you're just, because you build it, doesn't mean that it's per se secure. So there should be no trust, and you can like point it out with like trust boundaries and etc. And that's the thing. In zero trust, we could dive into the technical type of that and say, okay, if I have like a front end and I have a back end, I have maybe some API clusters there, and maybe another EIM tool, and everything should work together for a finalized product, but for the communication between these components and layers and everything in between, you need to think that you can't firstly trust it. So you need to establish some secure connections. You need to maybe have like some cryptographic libraries in place which you can use and utilize for all this kind of concepts. If we are going to the next little bit picture, is defense in depth. Defense in depth is a concept which you don't see only in application architecture, but also in IT architecture in general. It just means that we have a layered defense of security, and application is, or software is just a part of that. And what we mean by that is that we don't use just one part of or one layer of security, but use several. And that's just because if one layer fails, another one will protect your system. So in conclusion, you know that if you have like a prevention or detection system, you can only do such things a little bit. But if you have like an application architecture and thinking about it, like, okay, maybe I have some security mitigations or secure like application security mitigations for the front end, and they can't fix everything. The backend could get the request even without working with the front end. So just a layer, you have like implementations for mitigations in the front end, but also in the back end, and also in between the networks and system layers and so on. If we put the lens a little bit more into the software layers, you have multiple software layers. You have like the application, you have the presentation of it, you have the business logic behind that, and data access, and data, of course, is the laying underground of all of that. So if you're thinking a little bit about the software layers in definition, you can think about that in that kind of that sometimes in multiple layers there could be different or similar or also the same security problems. So if we're looking at that, you should log critical events on all parts of the layer, but you have like something which is only mitigating on some kind of layers and sometimes on different layers. If we look at, for example, input validations, this is done on presentation, business, and data access. The principle of least privilege, POLP in short, many people know it, is just the principle of providing only the amount of access and permission required to perform a specific function and nothing more. So an admin shouldn't do everything, or like in the context of application architecture and EIM concepts behind that, that you have like maybe some kind of dashboard admin for the product you have, but this admin for this shouldn't do everything, just maybe a part of that, what the admin on this dashboard should work on. Also a consumer or user of the system, they should only do a little bit of that. And what I am saying most times there is just use RepoKit. And RepoKit is a really, really good free open source tooling you can use for that kind of enforcing this principle of least privilege. If you look at example for the AWS MongoDB interface for that, you can see that there's different permission sets. Like for the API, you see it for the LDS data store, you see it for the message queue, but also for the KMS keys. And enforcing POLP is that mundane that maybe sometimes you forget it. And you can use it for every part of architecture design. If we are looking at principle of failing secure, most times I get the questions, okay, when we failed, it's an error, okay, well, we can fix it after that. I don't mean it by that, because if you have like following the principle of least privilege, and you have, for example, in this building or in your organization's building, a security badge for getting into the building, and when you go only with principle of least privilege, your security badge would only access your areas to maybe your specific workplace or like the part of the building where you're working on. But if you're saying, okay, what happens if power goes out? Okay, is maybe everything open now? We don't know, because we didn't test it. We didn't think about all of this case. So failing securely means that we should also have something in place when some side things happen we didn't expect earlier in the process. Or if other things, not just in case of our application design, is maybe one container not working anymore, or one service not working not anymore. What happens if this doesn't happen? And maybe the API for the connection with the front end is just openly now, and now an attacker can leverage that. And we doesn't want that. So what I mean with failing securely is just like this example. We are just like doing some things, and I will come to that in the next second, or I will tell it right now. It's called security chaos engineering. So maybe who knows chaos engineering? Maybe, okay. No one? Okay, that's good, and I can tell you something you don't know yet. That's good for me. Chaos engineering just means this kind of failing securely. We are predicting some kind of chaos events, and what happens if this chaos gets in time? What happens when we put like delete a user which shouldn't be deleted, or what is our core service not working anymore? What happens with all the other applications or with our network? And if we are looking a little bit into the CIA triad, or like the dependability, because we are talking, when we are talking about failing security, we are always dependable on something other than we are not focusing right now. For example, our application architecture. And if we are looking at dependability, we have confidentiality, we have integrity, we have availability, we have safety, reliability, and maintainability. Okay, you can read it. So, and if we are looking mostly in security, we are seeing CIA. So dependability is more than just like the CIA triad, it's all of the things I've mentioned. If we are looking, for example, to stay at the cloud architecture or application cloud architecture, we could do this for an example for an AWS project. And if you are looking, these are some possible security chaos engineering events we could trigger. For example, and I think you in the back don't see it that clearly, so I will just announce some of them. The user configurations are changed and privileges are group. What happens if we modify some user? What takes that place in their whole application architecture? But also, we are creating new roles. What happens with the new roles when they don't have some events under that, or like some business logic behind that. What happens with that? Are we automatically admin? We don't know. So we're just creating some chaos events to make something which we didn't predict earlier. And you could use some open source toolings for that. An example, these three. This could be from Netflix, the Chaos Monkey, but you can also use CHAP or the Chaos Toolkit, which helps you identify some kind of chaos events you could have in your environment. If we are talking about supply chain security, and I think we also are like halfway through about the principles. All of us know it. We have so much of third-party libraries or dependability on other software artifacts. And all of these, and that's why I'm saying, okay, supply chain security is also a big, big thing. Because if you look at how much is used by self-written code or with custom code we've written in our company, but how much we use it of third party. And I don't know if you know it, but you can say like 15 to 20% is custom or business written code in your built artifact from your software project, and 80% is third-party libraries. And I think, which will be a topic today and tomorrow, will be the XZ library. I don't know who got the news about the XZ library. Okay, that's not a problem. XZ library just was a Linux utilizations tool where, if you can say it, the whole internet depended on. And just one kind of person noted that there's some performance issues and was like, oh, what did happen? And the problem there was that this was like an attacker who got into this working group of the software, of this library, of this open source project. And it wasn't in the code per se, it was just in the build artifact. And with that you could have compromised so much more websites and tool stacks and websites and so on and so on. It was a Microsoft engineer, yes, correctly. I forgot his name, but he was celebrated as a hero. Thank you. And if we are looking all of the components, libraries, frameworks, and other code you did not write, is your supply chain. And each dependency needs to be secure. And fun fact, or funny, because we don't want to bash SolarWinds today or tomorrow. So I won't bash SolarWinds, but I think SolarWinds was one really good example of why supply chain was or is a big problem, and we need to secure it. And I won't go into the details and bash SolarWinds more as they already have been in the last years, but it's a really good example. And if you are looking at and I think now it's really bad readable from the back, but that's not a problem. If we go into the outer circle, we have a supply chain risk management where we are talking about customers, where we're talking about indirect providers. We can manage to a grade. We have a third-party risk management where we are looking at the open source dependencies we are using, for example, XZ or every other library we use in our custom-written code, but also the free software as a service tools we are using in our product. And then we are going one point deeper, the vendor risk management. So we are looking at the paid software as a service tools and paid on-premise tools we are using. And for every part of this area, you can look at, okay, what is written in this code. Maybe when it's open source, if it's closed source, you can't, but you can give the paid vendor you're paying the vendors to make it secure and maybe do some requirements to them and say, okay, how can we make it secure for you and me? And if we are looking at a circle for that, we are talking about dependencies management, we are build packaging, distribution, deployment, and compliance, and this will go in circles and circles and circles and circles. But with that, we can ensure that we are having dependable and secure dependencies or third-party libraries. And security by obscurity, I have this discussion on every time I talk about it. And they are saying, Rico, why are you preaching security by obscurity? It's bullshit. You know. And sometimes, just like in this picture, they will want to flame me. They're saying, okay, you're preaching security by obscurity. You don't have some kind of knowledge. You don't have expertise. What are you talking about? And sometimes, often, there is the Kirchhoff principle, or it's called what you're most times saying if you're talking about security by obscurity, you're also talking about the Kirchhoff principle. And the Kirchhoff principle, and this is like where meanings, where the people are discussing left or right, is that true, is that not true, is it good, is it not good? A cryptographic system should be secure even if everything about the system except the key is public knowledge. And we know in the past, if we look at RSA or RSA, and we moved after the Snowden revelations to more of the Diffie-Hellman key exchange. So even if the key is in some kind of public knowledge or private knowledge, you can gather this information somehow. So let me put it into a real-life example. This would be a really bad example of security by obscurity, that you put your password on paper under a keyboard. So to put it into the meaning of this principle, and this is why it's often discussed, there are some pros and there are some cons to that. But because it's often compared to security in dev, we are talking about multiple layers. Or security obscurity on one layer won't work. But if we put it in combination with defense and dev, you can make it a little bit more valuable. And the thing is that the discussion often ends in, okay, if we do security by obscurity on one layer, it won't work, but will it work on multiple layers? Multiple layers? Yes and no. Yes, because the attacker needs to get a little bit more of cost, and then we are going earlier to the path of least cost or least resistance. And you're making it a little bit more difficult maybe for a script kiddie, but for an APT, they won't be getting back or getting thrown back from that. A big part, and this is also similar to our supply chain security, is the attack surface reduction. We should remove any unused parts of code. This could be third-party libraries, but it could also mean that everything what is not used, we are removing. Oftentimes I see in projects where I do some code reviews, okay, there's a to-do. Okay, when did you put this to-do in your code? I think it was like 2 years ago. Okay, is this part of the component used? No, but we had this sprint planning in our software development project, and we said we want to do that, and we have it in our backlog, and we really, really want to do that. Yeah, but why it's not done in 2 years? You can like to put it into not a build artifact and remove it. Yeah, okay, that's what I mean by that. So remove any unused parts of your code. And also, every part of your apps and systems is part of your attack surface. And there are many vendors who are doing like some kind of attack surface management, and they were looking at your IPs, your software you're using on your deployed website or on your systems in your IP range. And if you're talking about that, you should be known, or the vendors, they have a good point, because everything you're using is part of your system, of your ecosystem. In conclusion, if there's software you're using for your website and this is not longer maintained, you maybe have a problem in 1, 2, or 3 years. Maybe you need to think about some alternatives. Badum. Okay. Everything good? Okay. Also, the less you have, there is less to attack. So, for example, on this picture, all the bad people, they are going to the big house because I know there's so much in there and I need to attack it because probably I will get so much money or so much expertise from this project I'm working on. And on the left side, we have a house, pretty small in comparison of the big house, right? And there's no one, because all of the people are thinking, okay, there's nothing to attack, it's just a small house. And you can map it into like your software or application architecture. If there's less in your architecture to attack, you know where I'm going with the sentence. And a big part of every principle or every software architect I'm talking to is that, okay, we have so much principles and we could deep dive in all of them, and they have so many methodically and technical solutions for every part of that. But it needs to be usable. And I like to use this picture because on this picture is saying there's a group of people. Security is more important than usability. And in a perfect world, the other person says, no one would be able to use anything. And then we have in the last picture a person staring into a monitor. To complete the login procedure, stare directly into the sun. So in security context, it would be perfectly fine, because it's like multi-factor authentication, and I know we have some topics on covering that. But in that part of, okay, why should I look into the sun? It's hurting my eyes, and then I can't work anymore because I can't look into the monitor. And a good example for how it's not good is PGP. Pretty good privacy, I think it's in outwritten. And of course, PGP had some kind of use case, but for the most of us, I think we know that PGP isn't that secure as we wish it to be. So if we are talking about usable security, is what I'm saying, and this should be in every architecture, keeping in mind that it's done in architecture reviews or things like that, that if a security features cause a problem for the users, they will find ways around them. And that's just like what I'm saying in the first slide. They will find a way around that, because maybe there's another way. We are human, after all. I think AI won't go the creative ways human go right now in matter of security assessments or everything in this part of mythology. Compromises and creative solutions can lead customer delight and better compliance. So if we're talking about usable security, and if you're implementing some security mitigations, you should always keep in mind that if you're putting it in there, it shouldn't have a bad effect on the customers, on the users or consumers of your product or project, because with every implementation, there could be some backlashes. And with every backlash, maybe you lose some business. And if I'm talking to C-level people, and maybe some of you are C-level, and that's perfectly fine, that they are looking at the business first and security maybe at the third or fourth or fifth option. And so if you're using it, we use it in a context that it works for everyone, for the security people in different layers, but also for the customer, so he won't or she won't have a kind of problem with our product or project, but also the business side won't have a backlash on that. And we could look into usable security principles, an example from Kai-Ping Yi. And this are saying like, and we are seeing here many principles I said earlier. We have a path of least resistance, we have an appropriate boundaries principle, which are saying, okay, we are looking at how is our architecture working in a matter of security and usability. We are looking at the explicit authorizations we are doing for this, the visibility, revocability, expected ability, the trusted path. So if we are looking at UX, user experience, they are also, we are human, we are always doing the trusted things we know. So we are going the trusted path. Okay, if we have a trusted path, most likely people are going that way. For the other ways, we could do some security curse engineering again. The identifiability, so if we know something, as I said, we will do it more likely. The expressiveness and the clarity. And if we are putting everything together in one big box, it could be example this framework, the open source, open security architecture, in short, OSA. And this is just one part of the thing. OSA not just focuses on application architecture, but in IT architecture in general. But if you are looking at there, and that's some principles just in another word constellation, we have like architectural principles, for example, simplicity over flexibility, usability over restriction, and defense in depth. We have some implementation principles. We have an open design, because towers and eyes can see more than 4, for example, black box and white box testing or secure coding principles, and also in the matter of operation and configuration principles, complete mediations, least privilege, and audit trails. And if we spin it a little bit into, and that's what I'm always preaching a little bit, just so you heard it one time, or you can go after the session and say, okay, I learned some things about application security architecture or secure design principles, but also some kind of AppSec, because I know some of you people are not AppSec, but also everything I'm showing after this topic can be implemented in somehow the software development lifecycle. And example, application security, testing, if we are looking, okay, we can do some kind of testing on the operating system. This would be a dynamic application security testing, DAST for DAST in short. We have some kind of SAS tooling. SAS is like static application security testing. So my self-written code, my custom code, which is going to be reviewed. I have some IAST, interactive application security testing. So this is running on, for example, in this kind of on my Java virtual machine, my JVM. And now we are circling a little bit back to supply chain security. There you can use SCA, software composition analysis, where you can get this in a standardized model, for example, Cyclone DX, and check it for vulnerabilities in your supply chain toolings you are using. What you also can use for like the requirements or design phase is threat modeling, so just asking multiple questions, why, how, where, and so on. And you could go with some frameworks inside of that. For example, the STRIDE methodology, where you're looking at different topics of what could happen and how we can categorize it. for example, in the reputation, in the information disclosure, but also the denial of service. Just some examples of that. There are many open source knowledge websites, wikis for that. And what we are doing with threat modeling, we are setting some kind of objective, like we are an example for application security, want to secure our service X or our service Z, and we visualize it, and that's where architecture plans for software comes in hand. If you don't have one, you should, or you're going to need one for this kind of assessment. So you visualize your what is talking with who, this service with this service, and this server with this server, and then you can identify the threats for this kind of architecture review. After you know the threats, you can mitigate them, and after you mitigated it, you can validate it after some time if it's if the security mitigations you put in place are working or not. And if you still want more information, you can use, for example, the Open Web Application Security Project lists or the Application Security Verification Standard from OWASP. An example here, this is 4.02. There are some different versions. We have everything in our area in IT security. And you have some legend on that for like, okay, what is acceptable, what do I need to do I need to do optionally. And it's split into some kind of focuses like secure coding, and also on like DevSecOps. Like if we talk about the mythology, you can also, it's just not a code business, it's also a people business. And with that list, you can have like a checklist to see, okay, am I good, am I not good? Am I not compliant with any of those levels they are telling me? So it's a really cool project. And if we circle back to if we have implemented everything, I use this kind of picture in all of my presentations. We want to have like something like this. We want to have a castle where, for example, I'm sitting at the top of this castle and someone wants to attack me. And if the attacker starts at the bottom, where the two people are standing right now in this picture, he or she, or the attacker in general, needs to do many things to get to me. And maybe I have like some alarming system there, which can be used if they are trying to intrude my castle. And I can mobilize maybe some fighters. I have maybe some people who are shooting arrows at them as soon as they intrude. And an application architecture should look like that. A castle with different types of layers, with different types of mitigations if we are going to be intruded, and also some kind of in place that I know it and how I can mitigate it, and so on and so on. I'm finished for my presentation. We have now 10 minutes time for questions and discussions. Yes. We're waiting just a minute. Thank you. Let's do it with a micro so everyone can hear what you're saying. Otherwise, I use this time for the microphone. New was told to me, we have some kind of feedback package at the end of this room. So after you leave this session, please give me a feedback. With green is good and yellow is okay, and red is you talked bullshit.
Working?
I think it's not working. It's on?
It's on.
Okay.
Okay. So I have a question regarding supply chain security. Let's say you have a customer who lacks maturity in governance and risk management areas. How do you start your assessment? What do you do? Do you rely on some framework, or you have automated tools which we are using?
It depends, because I'm a consultant. You know, my answer will be for every question you ask me, I will say it depends. But in this case, it depends, because if you're working with a small startup, they won't have the business value of buying some big vendors like Sneak or Checkmarks. They won't profit from that. So what you can do in this kind of constellation, you are working with, for example, Cyclone DX as a standardization, and the OWASP tools like dependency track and check to get the first kind of information about is my supply chain secure or not. But that's just like a part of it, and it's just a public database where you know some kind of maybe right, maybe wrong, maybe some kind of other business told this is an issue. So this is an open public database, but you get a first feeling if there are some big threats on that. So this would be my kind of first assessment I'm talking about. But if you're not a startup and you're like a Fortune 500 company, you have other problems. You have not only open source toolings you're also using paid toolings. You are also using mixed from other parts of your company, some kind of library maybe, and you need to ensure that it's everything in place. And this is the hard part. So the assessment for the landscape is easy, but to utilize all the knowledge you have, that's the hard part. And this is you can compare it to the presentation from Jason, that this is not the sexy part. You need to implement some kind of tools, and then you can use, of course, open source toolings. And to answer your question, like checkmarks, no, not checkmarks, like the open source toolings from the OWASP project, like dependency track or check. And but to utilize it more, maybe you need a paid version, like Sneak, checkmarks, or other, or Man, for example.
Okay, thank you.
No problem. There's a question in the back of the room.
Hello, thanks for the presentation. I wanted to ask you about an architectural principle of simplicity over flexibility. I'm not sure exactly what does that mean, and I wanted to ask you if you can give an example or maybe explain it a bit more.
Yes, of course.
Yes,
So if we are looking at open security architecture, so open security architecture, maybe I need to clear that a little bit again. It's a framework you can use, and it doesn't mean that I stand behind it. But how I understand simplicity over flexibility is that sometimes you have some components in your architecture which don't need to be flexible. You use it for just one part of your software. And therefore, maybe this part of, and you can maybe map it to attack surface reduction a little bit. So maybe just is a nightly job for migrating something, and you don't need to scale it in some kind of flexibility, and keep it simple. So this is how I understand simplicity over flexibility. Perfect. We have one question here.
Could you please explain a bit more in depth what the security through obscurity means? Personally, it's the first time I've heard of it, and I'm not really sure what it entails.
Of course. That's why I'm here. So security by obscurity most times means that I'm putting something in place to obscure it. So for example, this one, but as also, okay, I'm hiding in plain sight. You can see me right now, correctly? So now I'm putting maybe my laptop and this desk before me. Now you can see me partly. And I'm trying to hide something which is publicly knowable. So maybe I can put like magician something before me, and then you can see me, but you know I'm behind that. So you just need to move like one point left or one step left, and you can see me. And the obscurity is just a layer you're putting around it. And that's what I've said, multiple layers. If you're knowing, okay, I'm standing right now here, and we have like some kind of wall before us, and you can move one step. But what if we put it into another perspective? I have more walls around me. Now you can see me, even if you step one step left, 1 point to the right. And that's why it's heavily discussed. So is obscurity really a secure design principle or not? But you can use it to, like, even if you walk around, then you can see me again, but it would be more path to walk for you.
I understand, thank you.
Perfect. Do we have some more questions? Okay, it doesn't look like, and we have like 3 minutes left, so you will see me here today and tomorrow. So ask me, shoot me with some question. Otherwise, you can add me on LinkedIn. I will answer all of your questions. And as I said, feedback is in the back. Yes? You have still one more question? Okay.
Can you explain the difference between testing exercise and chaos engineering? I know there are some differences, but can you maybe emphasize?
So you mean application security testing and chaos engineering?
Yeah, correct.
Okay. So chaos engineering per definition is simply a methodology first time, and you are putting like the technology second, and you're thinking about chaos events. You are thinking about what can happen if I remove something or if I add something which shouldn't be there. And application security testing is technology first and methodology second, because with that I will check in real time or not real time if there are some vulnerabilities in my code or in my software. So the other thing is I will first think as a person and then put something in place. For example, that I'm removing something from my software layer or from my network layer. And application security testing just means different variations of how I can utilize some tools, for example, Sneak or Mend or other open source toolings. Those were paid tools, but open source toolings you can use also, where you're checking for vulnerabilities in some custom code or for the artifacts. Understand?
Okay, thank you.
Perfect. Are there any questions? If not, then again, this was a little bit too fast. Thank you very much. Have a good time and see you.